Okay, guys, today we're going to talk about rational expressions, and the first thing that we need to discuss when it comes to rational expressions is the idea of simplifying them. Okay, now, first of all, what do we mean by a rational expression? We mean something that is a quotient of two polynomials, right? And of course, whenever you have a quotient or fraction, right, so you can think of this really as a polynomial over another polynomial. Of course, as long as that polynomial that's in the bottom is not zero, right? Because then you have a problem. Now, in order to simplify rational expressions, we're basically going to use the idea of the cancellation principle for fractions, right? So really what this rule says, I'll write it out sort of in symbols first, is that if you have common factors in the top and the bottom of a fraction, you're allowed to cancel them, right? Now, usually most of the time we don't think of it this way. We think of it more as something like if we have, say, 6/8, right? And we know that we can divide the top and the bottom by 2. We get a 3/4. Now, what you're really doing there is you're essentially thinking of 3 as 3 times 2. You're thinking of 8 as 4 times 2. And then at that point, you can cancel the 2's out, and you're left with 3/4. So that's sort of the idea that we're going to use to simplify a rational expression. Okay, so let's look at some examples. So in part A, we have a negative 4 x squared y over 8 xy squared. And these sort of examples we looked at a little bit when we did the dividing polynomials, right? And again, basically the idea is we just look at this component by component. So if we look at negative 4/8, we can simplify that to a negative 1/2, right? Then if we look at our x's, we have x squared over x. So that's going to leave us with an x in the numerator. And then finally, if we look at our y's, we have a y in the top and the y squared in the bottom. So that's going to leave us with a y in the bottom, right? And typically we would write this answer, instead of negative 1x, we would usually just write negative x over 2y, right? But even if you had this answer, that would totally be fine as well. Okay, let's look at part B. So in part B, we have negative 6 times a minus 1 times b plus 1 squared over negative 21 a b plus 1. Okay, so again, we're doing this piece by piece. So if we look at our numbers out front, we have, we have negative 6 and negative 21. So it looks like we can not only take a negative out of both of them, but we could take a 3 out of both of them. And that's going to leave us with a 2 in the top and a 7 in the bottom. Now, what you'll notice about a minus 1 and a is that although they're close, they're not quite the same, right? And we don't want to distribute because then we're not going to be able to cancel anyway, right? So we can't do anything with either of these terms. So a minus 1 and a both have to stay. But now we can look at b plus 1 squared over b plus 1. And if we consider that as just a singular number like it is, that's going to leave us with one factor of b plus 1 in the top. Okay. In part C is a lot like part A, where we have 14ab to the third over negative 63a squared b. If we look at our numbers out front, it looks like I can divide a 7 out of both of them, and I'll get a 2/9. If I look at my a's, I'm going to have one extra a in the bottom, and I have a power of 2 for my b left up top. Okay, part D, we have a 9 times x minus 1 squared times y squared plus 1 over 3 times y squared plus 1 times x minus 1. So here it looks like if I look at 9 over 3, I'm going to be left with a 3 in the top. They're not quite lined up, but my y squareds plus 1s are actually going to cancel. And I'm going to have one factor of x minus 1 left in the top. Right? So actually, I end up with nothing left in the bottom, so we just get a 3 times an x minus 1. Okay, so those are a couple examples. Now, I think one thing that I mentioned before is the idea of if you have something like negative 1/2, negative 1 over 2, or 1 over negative 2, these are all equivalent. However, most of the time we do write it in this form. So if you end up with a negative either in the top or the bottom of your rational expression, it's usually going to be best to write it in the form with the negative out front. Okay, equivalent. Okay. So now the ones that we've looked at already were already completely factored for us, the rational expressions that we've already looked at, right? Now, if they're not factored, we can't do much as far as canceling yet. So when it comes to simplifying rational expressions, your first step, really your first two steps, are to factor both the numerator and the denominator as much as you can, right? And then you just do what we did in the previous example. You cancel the factors that you see appear the same time, right? So let's go ahead and we'll look at an example. So in part A, we have x squared minus 4 over x squared plus 5x plus 6. Now in the top, you have your difference of two squares, right? So we know that that factors as x plus 2, x minus 2. Right? And in the bottom, that is our quadratic with our coefficient of x squared equal to 1. So we just need two numbers that multiply to 6 and add to 5. So those are plus 3 and plus 2. Right? And if you need a refresher on this factoring stuff, you can always view my video, view the previous video on factoring quadratics. All right? But at this point, we can now cancel our x plus 2's since they're common. And we're just left with an x minus 2 over an x plus 3. Okay, so that's part A. In part B, we have a 4 minus x squared over an x squared minus x minus 6. So if we factor this, top again is a difference of two squares, only it's sort of in the reverse order. It's now 2 minus x, 2 plus x. And then in the bottom, I need two numbers that multiply to a negative 6 and add to a negative 1. So I need negative 3 and plus 2. So since x plus 2 and 2 plus x are the same thing, they're each going to cancel. And I'll be left with a 2 minus x over an x minus 3. Okay. Now part C, we're going to have a little bit more work to do in terms of factoring, but still nothing we can't handle. Right? Because in the top, I can factor out an x first, and I'll have an x squared minus 1 left over. But then again, we can factor that second term into an x plus 1, x minus 1. All right. Now this quadratic right here, we need to factor using our a times c method. Right? So in this case, if I look at a times c, I have 2 times negative 3, which is a negative 6. So then two numbers that multiply to negative 6 and add to negative 1 would be negative 3 and positive 2. So I want to think of this now as 2x squared minus 3x plus 2x, and minus 3. So now we'll factor by grouping. All right, so we'll group both, we'll put a plus in between, and we'll factor each set of these parentheses. And again, if you need a refresher on how to do this type of factoring, you can view that previous factoring video. But it looks like I can take an x out of the first part, and I'll have a 2x minus 3. And in the next part, I already have 2x minus 3, so we're just going to take a 1 out. And then it looks like once I factor everything out, I'll have an x plus 1 times a 2x minus 3. So finally, it looks like we can cancel those x plus 1s, and we're going to be left with x times x minus 1 over 2x minus 3. Okay, so that's completely simplified now. Okay, now one thing to keep in mind is that you need to have everything completely factored and in order for you to be able to cancel something, right? So for example, if you have something like 2x minus y all over x, you're essentially treating this thing in the top as one number, right? So since 2x minus y is not the same as x, this can't be simplified anymore. Right? If you wanted to simplify something like this, you would need an x out front here, right? And then you could cancel those x's. But since we don't have that, that's the best we can do with this one, right? So that's one thing to keep in mind. Okay, now I want to show a technique that you can use by being a little bit sneaky with a negative, and that's going to help you to simplify some of these things even further. Okay. So in part A, we have x squared minus x minus 6, which we just factored in the previous slide, over 3x minus x squared. Now on the top, so again, we just factored that one, but we would need two numbers that multiply to negative 6, add to a negative 1, so that's minus 3 and plus 2. Now on the bottom, you can take out an x, and you have a 3 minus x, right? Okay. Now, we're kind of close on two terms, right? The x plus 2 and the x are sort of on their own, but x minus 3 is in the top, and we have a 3 minus x in the bottom. Now, they're not the same, but they're close, right? They're sort of off by negative. So what we're going to do is we're going to multiply the top and the bottom by negative 1. Okay, now I'm going to use the negative 1 in one of my terms, but just sort of leave it on the outside in the other one. So for example, I'm going to leave the negative 1 alone in the top, right? And then I still have x minus 3 and x plus 2. Now on the bottom, I'm going to take that negative 1 and I'm going to distribute it into this part right here, right? So that way this becomes a negative 3 plus x, right? Or if you like, we can think of that as x minus 3. Right? Well, now those x minus 3's match and we can cancel them, right? So now our final version is negative 1 times x plus 2 all over x, right? So that's our final answer here. So without using that negative 1 trick, we would be done here, right? But of course, if we can use that negative 1 to kind of cancel some stuff out, that is indeed helpful. Okay, let's look at part B. So in part B, we have a 16 minus x squared over an x squared minus 3x minus 4. So the top is the difference of two squares, so that's 4 minus x, 4 plus x. And in the bottom, two numbers that multiply to a negative 4 and add to a negative 3. It looks like negative 4 and positive 1 will do that. All right, so again, we're in the situation where these two things are close, but they're off by a negative. right? So what I'm going to do is the same trick as before, where I'm going to put a -1 out front on one of them. And then in the other one, I'm going to actually use it to make this a 4 minus x. Right? So if I multiply the top and the bottom of this by -1, I can again get into a situation where I can now cancel those 4 minus x's. And then I'm left with -1 times 4 plus x over x plus 1. Okay, part C, we have an x squared plus 7x minus 8 over an x minus x squared. So it looks like in the top, we can factor that as a plus 8 and minus 1. And in the bottom, if we factor out an x, we're going to get a 1 minus x. So same situation as before. We're off by negative, so let's multiply the top and the bottom by -1. So again, just to make it different, I'll leave the -1 out front. Let's do it in the bottom this time, just to be different. So I'm going to have x plus 8, and I'm going to use the -1 to flip it in the top, so I have a 1 minus x, right? And again, that's coming from this being multiplied into that, and I'm going to leave the -1 out front in the bottom. So now these 1 minus x's cancel, and I'm left with x plus 8 over a minus x. And again, most of the time, we'll leave the negative out front, so we could say this is a minus x plus 8 over x. Right, and I could have done that, I guess, in this example too. Okay, part D, we have a 9y squared minus x squared over an x minus 3y. So the top is a difference of two squares again. We got 3y minus x and a 3y plus x. And then over an x minus 3y. All right. Now again, here you got to be a little bit more careful because all of your terms have a 3y and an x in them. All right, but only this one and this one are off by a negative, right? Notice that in this one here, the 3y plus x, the x's already have the same sign, but the 3y's have opposite signs. In this one, they have opposite signs, so that's the one that we want to use. So if I multiply top and bottom by -1, and I'll use it in the bottom, I guess. So we have a -1 out front here still. And then 3y minus x, 3y plus x, over, and this will then become a 3y minus x. So now these cancel, and we're left with a -1 times a 3y plus x. Or again, if you want, you could just even drop the 1 and say it's -3y plus x. Okay, so that concludes this video on simplifying rational expressions. I hope you enjoyed, and I will see you next time.